Now look at the question. A string ABCD hangs from fixed points A and D. So A and D are its ends, B and C are somewhere in between. It carries a mass of 50 kg at B and a mass of m at C, and AB is inclined at 60 degrees to the horizontal, BC is horizontal, and CD is inclined at 30 degrees to the horizontal. Determine the tensions in the parts AB, BC, CD and the mass m. You can take G as 10 if required. So if you carefully look at the question and try to draw the diagram, you understand that A and D are 2 points at the ends from which a wire is hanging. In the question it is given that BC is a part which is horizontal and AB is a part here and CD is the other part, and a weight is attached here 50 kg and a mass, this is mass 50 kg and a mass m is attached there. This AB is given making an angle 60 degree, whereas CD is making an angle 30 degree. So this is the information as per the given question. You can check. So read the question again and look at the diagram whether the question is satisfying or the diagram is satisfying the question or not. You can check. Now this is one point where the wire 1, wire 2, wire 3 and the wire 3 of course is attached with 50 kg. All three of them are keeping this particle B in equilibrium, and the force in this wire and of course the same force in this wire and this mg weight are keeping point C in equilibrium. So we have two junctions, so we need to apply Lami's theorem twice. So let us put the forces here. Let the tension in this wire is TAB and the weight here 50 kg. Mass is 50 kg. When mass is 50 kg, we know weight is 50 g mg. 50 multiplied by g taken as 10 makes it 500 Newton. So when mass is 50 kg, the weight in Newton is 500. This is the other force. The third force in BC, we call it as TBC. So here we call TBC. But here the string has the two ends, So at B, the tension is to the right hand side, because we know tension in a wire is always given by two inward arrows. So here we take inward arrow to the right, but at C the inward arrow is going to be to the left. So the same TBC acts to the left here on this point and it acts to the right here on this point. That is about the property of tension, inward arrows. And here we have the weight of this one, which is unknown because mass is m, it's mg, and the tension in the part CD is TCD. So these are the forces. Now let us put the angles. So we know this is 90 degree here, here also either way you can write this is 90 degree. So this is also an angle required because this is the angle between TBC and the weight, and this is 60 degree here. So what about the remaining angle? It's going to be 120, and here we want the angle between the tension here and the weight. This angle is required. From here to here it's 90 plus 60, so this total angle makes it 150. These are the angles here. If you go there, this angle is 90 between this tension and the weight. Since it is 30 degree here, the remaining angle is 150. And now from here to here, if I take total between the weight and the tension in the wire, it is 90 plus 30, 120. So all the angles are known. So now let us go for applying Lami's theorem at the first junction. If you apply Lami's theorem at B, we know each force upon the sine of the angle between the other two forces is constant. That is Lami's theorem. If I take 500 force, known force 500 upon sine of this angle 120 is equal to, if I go for TBC, this one TBC upon sine of the opposite angle 150, that is TBC by sine 150 is equal to TAB upon the sine of opposite angle is 90. So from this, if I take the first one and here everything is known and here only TBC are known. So equating these two we get, or equating this and this first, we get TAB is 577.36. You can simplify yourself. Both are known, denominator known, only numerator is unknown. So we can equate these to get this, and then equate this and this or this and this now, because we know TAB also. Otherwise equate this and this to get TBC. So we got TBC as 288.68 Newton approximately. So this is applying Lami's theorem at the first junction. So in doing this junction, we found the value of TBC. Now the same TBC acts here. So for this junction, this will become the known force and the other two are unknown forces. So using this known force, we'll be able to find out the other two unknown forces, that is applying Lami's theorem to the junction C. If you take TBC, that is known force. So I have written TBC even though I know the value, later you can substitute. So this is known. So TBC upon sine of the opposite angle. So to this, the opposite angle is this one between the other two forces, 120. So sine of 120 is equal to, if I take mg upon sine of the opposite angle 150, is equal to the third force TCD upon the sine of opposite angle 90. So, here everything is known. Here you know this value TBC you can put here. So, both are known, and this is known. G you can put as 10 as given in the question. So, unknown M can be estimated by equating this. You get M as 16.66 kg, and you can equate this and this, putting TBC here, the unknown TCD can be calculated. So, we get the tension, the third one TCD is 333.34 Newton. So, this is the mass, this is the mass to be hanged here, and if that is hanged, then only the part BC will be horizontal. Suppose if this mass is lesser, the point C goes up, if it is larger, the point C comes down. So, to keep the middle part of the wire horizontal, this is the mass to be hanged. Under those circumstances, these are the values of the tensions in the three wires. This is how we can apply Lami's theorem at different junctions and solve the problem.